Okay. No clue if I'm streaming because the YouTube interface. Okay. Alright, so in this stream, I would like to, yeah, maybe, I forgot my habits, but I should check the sound. Like to, alright, there is sound and I'm not talking in the void, epic. So, yeah, how do I pop the chat again? Pop out chat, there we go. So this guy can go somewhere else, and this guy can go there, and then this guy can come here, and then we can do mp3.4. So, the streaming thing can go on the side as well. Okay, so in this one I just wanted to, I don't know, just get back a bit into streaming for a little while. And I thought it would be nice, since in my latest videos I just explored syscalls, to just, I don't know, do the video preparation while streaming, I guess. So yeah, I'm gonna first look at T and splice, which I kind of already know what they do, but I haven't tried them yet. So let's do something like let's see. Let's try this. Let's make a little main. Like so, and man to T. So what T does is, the concept is like you have, Unix pipes and so on, and you have all kinds of file descriptors for everything, like files, sockets, and so on, and pipes. And so T is kind of like if you have a pipe, you can do a T junction. So basically, it duplicates the flow. And so yeah, it duplicates pipe content. So if you have an input, an input file descriptor, you can apply T on it, and then it will push that to another, duplicate this input for another file descriptor. And so it doesn't like really consume the input, it just duplicates it and feeds it to another source. So let's try to do that. And a splice is a way of moving data between file descriptors, but without interaction with user space. So if you wanted to move data, let's say from a network socket to a file, you would have to, if you would use read and write, you would read into a buffer, so copy in user space and then write that buffer to the file. Here you can like move the buffer, but everything is in the kernel and you don't ever need to copy data to user space. So yeah, this is a bit weird too. I forgot how this works. Yeah, like talking in the void for hours until there is one message in the chat. So let's start with what would be a good example. I guess we can just rewrite the T command. I know that the real T command doesn't use it, but we can start with that. So we would have int argc char argv like so, and we would say int file would be open argv1 in o rd only, like so. This would be fcntl, like so. T is also in fcntl apparently, and where is splice? It's also in fcntl. Great. So there we go. And so we would have to do some kind of T, and the input file descriptor would be std in fd. I forgot how it's called. God damn, I forgot how it's called. Std in file descriptor a macro. Can't believe I forgot this. file no. Now I remember. File no. So it would be, we copy it from std_in and we put it in the file, so fd, and then the size can just be, I think, uint 64 max. Like what this means is that it will try to copy like as much data as it can, and so of course that's not like the uint 64 max, but it will, I think it returns the copied size, something like that. And the other argument is a flag, so let's just put that to 0. Let's include limits. That doesn't exist? Huh. Max. I guess we can use that one instead. stdn file no, I assume, is in u std, and the t thing apparently needs define GNU source, like so. Okay, and so that duplicates the thing, and then I'm guessing what we should do is that I should call splice. Well, maybe let's look at the flags first. Computer is making noise. Move, no effect. Non-block, that's not for now. More currently has no effect. Unused, okay, this is for vmsplice. Okay, so basically, I don't know, they have flags, but none of them are useful except the non-block one, which I'm not gonna use. Okay, duplicates up to size byte from the pipe. So it has to be a pipe. Has to be a pipe. Well, let's try it. I mean, I will pipe something in the shell, I guess. I wonder if it works with like file redirections as well, but I'll try later. File descriptor fd_in into the pipe, so fd out also has to be a pipe. Okay, well, let's try it. Let's try it anyway, because I read, like, I know that the splice syscall was originally only meant for pipes, but in the latest versions of the kernel, they actually, if you specify like a socket file descriptor or a file descriptor, they create the pipe for you. So let's try it anyway, and if it doesn't work, I'll create pipe. Upon successful completion, T returns the number of bytes that were duplicated when input and output. Return 0 means that there is no data to transfer. And it would not make sense to block because no writer on error. Okay, just regular stuff. If copied size is equal to -1, which can just do p or to cd error. And I forgot PR, where is that? It's in stdio. Okay. I forgot this, and yeah, we can just exit failure, like so. I think exit is in stdlib. Up, like so. So, yeah, that's all for this. There's just this, invalid. So we're gonna get this one if it has to be a pipe. And this one, I don't understand why it could return out of memory, but I'm guessing we're not gonna find out. So now onto splice. Splice takes in fd in and fd out. It takes an offset, which I'm guessing is gonna be null in our case. Then there is a size and flags. Okay. So we t something, then we do spliced size is equal to, it's not an int, it's a size t, like so. I love C compilers not warning me about stuff. And so we splice it. So we first have to splice std in to std out, like so, and this is null, and this is null, and the size would be u long max, and the flags would be 0. Let's put that on multiple lines, like so. Not slice, splice. Let's do a die if kind of thing. Boom, boom, boom. Up, up, up. Just a tiny helper. Die if copy size. Et predicate size is equal to -1. Let's do spliced size like so. So now we spliced the std in to std out, and let's do the same thing, but this time we need to do it from the file. I'm guessing, yeah, that doesn't make sense because, okay, what does t? So fd in, fd out, duplicate up to size byte from the, hello, what is fd in t? What is fd in t is pipe. No, fd is currently just a file that I opened, but I'm pretty sure it's wrong. I'm just, I don't know, trying to write what makes sense and then running into errors and see how I can make it better. So t duplicates up to size bytes from data from pipe referred to by the file descriptor fdn to the pipe. Oh, so both of them have to be pipes. I see. So I guess there is no way around pipes. So stdin should already be a pipe, since we will just pipe some data into the thing. So this is a pipe, this is not a pipe. So I do need a pipe. Int just p is gonna be equal to pipe. That's not how the pipe syscall works. Like so. So there we go. And I always forgot a unidirectional channel. So 0 is the read end. Let's create a little helper because I never remember these things. Just type def, like so. We'll have a pipe t. I think we must both be pipe. No, I know the man page says it has to be both pipes. It's just that, yeah, I'm not sure. But yeah, indeed, now I see that there is no way to do a second splice if I don't have a pipe. So yeah, it must be a pipe. So anyway, let's just do this. Let's just do array, something like that, and then we would have a struct, which is an int, which is the read end, and then there's the write end. Maybe let's call this write fd and read fd, like so, and this would be, does that work? I think that compiles. So this way I can just have my pipe t, p, like so, and this would be pipe array. And so now I can just say read and write instead of always saying like 0 and 1, which is much more readable. So anyway, I have a file, I have a pipe, the std in is already a pipe, so now I need to t from one pipe to the other, and this other pipe would be p write. So it would be the write, end of the pipe. I think so. Yeah. So if we do a little schema, so I have std in pipe, then this needs to flow to another pipe, to well, p, which is a pipe, and so no, std in will flow to std out, which can be anything. And then what t does is that it creates a thing which through p, which is a pipe, we will redirect that to the fd, which is a file. Does that make sense? I think it does. I think it does. Yeah. Okay, let's try that. Let's put t on one more line so that you can see, maybe, yeah, whatever. Okay, so now I'm teeing to a pipe. Next, I splice the std in to the std out, so this is this part. And next, I need to splice the p read file descriptor to the file descriptor. I think that makes sense. Can I do something like this? Like so. Okay, let's try that. Oh yeah, I do need to close p like this. Okay. Yeah, sure. Let's do that. Let's see. And let's do echo hello into. We're gonna pass that to our executable, and as the first argument, I'm gonna put that in a file foo. Invalid argument. Oh. Okay, well, let's see if so t works alone. That's good. I'm guessing the splice is wrong. Okay, the splice is wrong. I'm guessing it's going to be the offset. I thought the offsets were optional. Splice. So splice data to from a pipe. But I can swear that I read the kernel mailing list, and splice actually works without pipes, or like if you pass it something that is not a pipe, it will like create an implicit pipes by default. So splice moves data between two file descriptors without copying between kernel address space and user address space. It transfers up to size bytes of data from the file descriptor fd into the file descriptor fd out. Yeah, where one of the file descriptors must refer to a pipe. But that's the case. No, here it's not the case. There must be at least one pipe and in splice. Yeah, I guess so. I guess so. I don't know. I guess. Yeah. But wait, std in is a pipe, so that's okay. Yeah, std in is a pipe, so one of the file descriptor has to be a pipe. There we go. That's done. The following semantics apply for fd-in and off-in. If fd-in refers to a pipe, then off-in must be null, which is the case. Okay. If fd-in does not refer to a pipe and off-in is null, okay, so that's not the case. If fd-in does not refer to a pipe, it does refer to a pipe. Analogous statement apply for fd out and offset out. Oh, okay, so it offset out does not refer to a pipe, then bytes are read from fd in starting from the file offset. and the file offset is adjusted appropriately. Yeah, but okay. If off doesn't refer to a pipe and off in is not null, then the offset must point to a buffer which specifies the starting offset from which bytes will be read from fdin. In this case, the file offset in fdin is not changed. Okay, so it is optional. Line 43, shouldn't it be splice size 2? No. It's spliced size 2 is for the second one, which is commented for now. This seems okay. I wonder. Okay, flags. Attempt to move pages instead of copying. This is only a hint to the kernel. Pages may not be copied. The initial implementation of this flag was buggy, therefore it is a no-op, but it's still permitted in a splice. In the future, a correct implementation may be restored. So I'm guessing this is useless. Non-block is the same, we're not going to use it. Splice more data will be coming in a subsequent call. Okay, now I see, yeah. This is to, like if you put data through a TCP stream, like the cork option will, if you have multiple tiny writes, it will combine them in one frame instead of sending like multiple tiny frames. This is for vmsplice, okay. Number of bytes, yeah, on error, -1 is returned, that's good, and invalid. So that's what we have. The target file system doesn't support splicing. Oh, okay. So does ext4 support splicing? ext4 file system support splicing. No, not Belgium. Ext supported file system, ext4, okay. Fully supported. Okay, I wonder if this site is AI generated, because I've seen it more and more, and it seems new. Seems new. The target file system doesn't support file, the target file is open in append mode. That is... Oh, I'm retarded. It's write only. It's write only. Maybe we can do fun as well, because why not? And we should do O create. We should also die if fd is equal to -1. Yeah. The target file abandonment, neither the file descriptor refers to a pipe. That's an offset was given for non-seekable device. Oh, I see, okay. Again, out of memory. I wonder... It doesn't duplicate memory or anything, so I'm not sure how it can run out of memory. Nice, seems correct now. Invalid argument. It's not correct now. So this is still the second splice, right? Yeah, it is. Check the type of a file descriptor, because I'm assuming that stdin is a pipe, but I guess maybe it's not. So I'm guessing this is SD is FIFO. Is that a thing? Nope. Man to SD is is FIFO. Check the type of a file descriptor. Okay. Let's do that. Printf is FIFO. stdin like so, and this would be stat SD is FIFO for SD in file no. Okay, so this can be null. Up, no, like so. And this is in include a system D SD daemon. Up. Like so. Okay. Function main, no reference to SD FIFO. Really? I'm guessing it's the system D library. System D. Okay, so it can just be L system D. It is. Okay, that's odd then. Okay, and if I check std out, it's not FIFO. If I check FD, it should not be FIFO. Indeed. If I check P, the read end, it is FIFO. If I check the right end, it is FIFO. So, okay. Why doesn't it work then? Maybe let's try to not T anything. Let's try to splice alone. So std_in is FIFO, so this should be null. And then std_out is not FIFO. And I feel like it should be null anyway. What if we do something like this and we do something like a cat so that std_in and std_out are FIFO? Oh, it does work. Okay. But if I do this, invalid argument. Okay. So man to splice. No, splice. So if FD refers to a pipe, it does not, so it's either one of those two. So if it does not refer to a pipe and of the offset in is null, so that's our case, then bytes are read from FD starting from the file offset. Starting from the file offset. Okay, but std_out is it a file? I don't know. File offset, and the file offset is adjusted appropriately. And offset is not null, then offset must point to a buffer which specifies the starting offset. Can you like so? Would that fix it? No, it would not. No, it would not. You don't have a French keyboard. No, I don't. Because the French, well, the Belgian keyboard is quite bad for programming. So, I mean, I look silly when I need to type mails to like a French, well, French-speaking administration because I can't put the accents and so on. Well, I can now. I have this, so I can pick an accent and it will insert it for me, like so. Well, apparently it doesn't work in Vim, but it works in real life. I agree. I use NC keyboard too. Yeah, it's the placement of the stuff is better. Also, it's, I don't know, it's more compatible with like Vim key bindings and so on. For accents, I use your key. Your key. What is your key? The European keyboard. Ah, you just switch layouts. I see. Yeah, I mean, I don't need all of that. I guess for some German thing, it's useful. But then I would have to learn all of this. But it's nice, I guess, because yeah, it's always an issue where, like, every time if you want to learn a new language or type the name of a city that has an accent, it's always missing from the keyboard. But I guess I just don't type often in French or other languages. It's not. It's pre-installed in most distros as EU. Okay. How do I do my stuff then? Because splice says that it can do from, like, only one end of it needs to be a pipe. And that's the case here. So the std out is not a pipe, but std in is a pipe. And apparently offset is useless, so I mean, I can remove that. Moves data between two file descriptors without copying between kernel address space and user address space. It transfers up to size bytes to a file descriptor where one of the file descriptors must refer to a pipe. I don't get it. If fdin does not refer to a pipe and offset in is null, then bytes are read from fdin starting from the file set. Look at the bullet points below. Yeah, that's what I did before. But so if it refers to a pipe, then it must be null. So this is the case here. If fd out, well, I mean, it says that those are valid for fd in and fd out. So if fd out does not refer to a pipe, so this is the case, and offset is null, then bytes are read from fd, are written, I guess, from fd out starting from the file offset, and the file offset is adjusted appropriately. Yeah, I don't know, this seems fine. What if the std out is also a file? Invalid argument. I'm pretty sure I'm doing something wrong. Oh. What if we just try to do something like this, and we just forget about std out for a while, and we just do fd and fd2. This is a bit confusing, but let's maybe rename it. So we will just try to redirect std in to two files. That should be okay. And this time I do need the pipe, right? Yeah, because I duplicated it, and so this I will close those guys like so, and now I need to say two files like this. Invalid argument again. Huh. I am highly confused. This guy is fine. This guy is not fine. But this guy was fine. What? It's not fine anymore. What happened? Huh. But this is a pipe 100%, and this is something else. This is a file. Do I need a pipe in between? But then what's the point? What is the point? Oh, yeah, well, of course, it won't work without a T. So you T this to this, and those are both... so the T works. I'm guessing I need to specify the right end of the file, not the read end. Oh, actually, wait. No, yeah, it has to be the right end. Wouldn't make sense otherwise. Well, maybe let's see some examples. I have this page, like when those new syscalls came out, they did a post. The new splice system call was covered last week. Maybe I should make this larger. For starters, the prototype, yeah, should be positioned prior to beginning the transfer. Note that these offsets are passed via pointers. User space use a null pointer to indicate something. Internally, splice code has seen a couple of interesting changes. One of them, in regular pipe code actually, is the creation of a new pipe node something. Okay, but I would just like to see an example. T-splice example. Et yeah, Linux. Okay, so there's this blog post. They do stuff with read and write, and then they show T and splice, and I would like to have a full example. So, okay. They have pipes. They have a lot of pipes. Can it only be pipes? But that wouldn't make sense. So this is accept a client, this is connect to destination. Uh-huh. I guess maybe I forgot how pipes work, because that doesn't look okay, because you create a pipe, but then you just overwrite the value. Pipe destination pipes. Oh no, okay, it's an array of arrays, okay. So they splice between a pipe and a pipe. This source FD is just a socket, so yeah, and they have null and they have something. Pipe buff size. Splicing from pipes to sockets. Does it just not work well with files? Yeah, I mean, I can just ask an LLM for this, I guess, instead of trying to read 50 billion characters of a thing. Let me just boom, 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 boom. Yeah, maybe you can do that. Does it work if I move it here? No, it does not. Okay, like so. Give me an example of the T-splice syscalls on Linux. Let's see. I mean, there are more things than pipe and files like sockets. Yeah, I mean, but it works on file descriptors, so yeah, okay. The LLM says that it can work on files. Trust your LLM gods. So yeah, this is pretty much the same initial setup as what I have, except that it has two files, and then it splices. Oh, there is not even a T. What the fuck is he doing? And T duplicates by continuing. I mean, there are more things that can be in FDs. Yeah, of course, but I mean, I still don't see why my example couldn't work, because I have files, I have pipes. Seems okay to me. So it splices stuff, but I mean, that's not really interesting. I wanted to I wanted to do something else with it. Well, I guess that's fine for splicing data from one file to the other without having to read write. But T was the actual interesting one. And out is a file. Now drains stdin in the file. T duplicates stdin, stdout, now drain. But this looks to me like, I mean, they have a while loop and so on, but that doesn't matter too much. This looks like it's only gonna write to the file. Why would it also write to the stdout? Does it just advance the whole input wherever it was copied? That's a bit strange. And yeah, and yeah, as well, like this is the same thing as what I have, except this. Is this because they said it doesn't matter, the flag? Like man to splice, and then they say splice move. Attempt to move the pages instead of copying. This is only a hint. Yeah, this doesn't seem important, and they said that it was buggy, and so they removed it. Can you please once write what we are trying in a simple message? Can you please once write what we are trying in a single message? We're trying to... I don't know. I was trying to kind of rewrite the T command, something like that, where it outputs stuff here and it outputs stuff to the file at the same time. Yeah, that was basically it. But instead of using read and write, I was trying to use the... Well, I am trying to use the T and the splice syscalls, which would do these operations without ever going to user space. Hey, what the fuck is going on? I just explained it, but yeah, I'm trying to check out the T and splice syscalls to see how Zero Copy IO works on Linux, or at least a part of it. But I am not understanding what's output to stdout and file from stdin without any copy. And file from stdin without... Yes, that's it. So yeah, all the memory will be moved in the kernel, and I will never have to copy the memory myself. So it will never go to user space. It will all stay in kernel space. Nice, never tried it before. Good luck. Thank you. Dankeschön. Well, let's try the... Oh! Did I just forget that? Could it be that simple? That would be quite dumb if that's the case. Invalid argument still, so okay, it's not that. This is not completely zero copy, just that one part. Well, I mean, it has to copy it, yeah, okay. Well, it's called zero copy on the internet, so what can I say? And in the kernel mailing list, they also call it zero copy. But yeah, then like the copying will happen in the kernel, that's what I mean. There won't be an extra copy in user space. But anyway. Okay, so let's try the very dumb thing. So let's remove the second file. Let's remove the pipe. And let's keep the T because it likes the T. Hey bro, which IT jobs role are gonna explode in 2030? I have no freaking clue. I'm not I'm not omniscient. I have no clue. And so it is from... Huh. This is weird. So it is std in to std out. That was the thing. Why would you do that? Okay, did I just misunderstood completely the T syscall? I am 11th, hence so confused AI, ML, or cybersecurity. I am in 11th. I don't know what 11th, hence so confused means. But yeah, I don't know, just do what you like and at some point try to make money from it. Or I don't know. I don't know. Don't let people on the internet tell you what to do. That would be my advice. T duplicates up to 6 bytes of data from the pipe referred to by the file descriptor fd_in to the pipe referred to by the descriptor fd_out. But that's not a pipe in your example. What are you building? I'm trying to understand the T and the splice syscall in Linux to do, well, zero copy of data when moving stuff between file descriptors. But I am not managing to because it's quite strange. Let's do something very, very dumb and do LLM splice example. And so, so the splice moves does not work, but LLM thing. Okay. And so that would need something like a... So it takes in a pipe, that takes in another pipe. Oh, so the file is the input. Okay, so I have to, I don't know, say a file, and I would say, I have to say, I don't know, bonjour, or hello, something stupid. Then I would have to say foo, which would be the input. And I would output that to bar, which would be another file. So did that even work? Okay, so that did work. It copied the content from foo to bar. But I don't understand. Oh, okay. So it's just showing how to copy stuff in this one. I see, I see. And so in this example, we don't have to do a read or a write to copy the file. We just used splice to put the file, the input file into the pipe, and then from the pipe to the output file. Yeah, that makes sense. I'm guessing it also works like this. Like so, and then it out, and yeah, I have to remove the guy before, and then do this, and then get bar, and then it exists. Okay. Okay, this is just copy. Yeah, like rename something like this. And then the other example was a LLM T example, like so. So ici, LLM T example. And then we need to say echo hello to a.out, and this would open copy.log and it should duplicate the output. It did not, so I mean it did not even put it in there. Yeah, if even the LLM can't figure it out, even such a simple example, this must be some pretty obscure shit. Sure, Mr. LLM, let's try the random stuff you spill out until there is something correct. No, that also doesn't work. I don't get what n does in the LLM example. Isn't the return value the amount copied, not the cursor? Let's see, n. Yeah, I think, I mean, it's not like the dumbest LLM, it's like Opus something, but apparently it seems to have trouble. And it's very weird because that's something that LLMs are supposed to be quite good at. So, okay, I guess we're gonna stop using LLMs right away because that seems extremely strange. I think, yeah, it's trying to see how much data was copied and let's move all the yeah, move all the data. But I don't get it. Yeah, it's doing exactly the same thing here. That's stupid. Okay, back to our main. It's harder than what I expected. I expected to have a little fun and that's all, but this is harder than expected. So can I do the most basic thing of like, let's forget about T for a second and let's literally just try to put the std in to a file with splice, and the std in will be a pipe. So that should work, right? I'm not crazy. Right. I just open a file, splice std in to this file, and yeah. I wonder if the what the fuck happened? I wonder if the ulong max is confusing it. Let's try with a I don't know. That's a bit of paranoia, but let's try it anyway. Main. Like so, and then I echo into this, and yeah, it will be to find foo. So this worked. Okay. Huh. So I can do this. That's okay. 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 So let's create a pipe. Let's create a pipe, and creating a pipe is fine. And then, okay, let's do something like this, and let's rm foo bar after. Let me make this slightly bigger. So let's do this, and let's get foo after. There is no foo. Okay, let's not do that, whatever. No, okay, it's the other way around. Anyway, I'm getting confused, but like this, and then get foo. Okay, so this still works. Now what I wanted to do is see if just calling t like this does anything. Does it, if I remove foo and I do this, now it's an invalid argument. Aha. So calling t made splice fail. I should also prefix, and I just put a prefix. So yeah, and here it will be t. Here it will be splice1, and here it will be splice2, just so that we can know which one failed. So, if, oh, this has to be, yeah, 51, sure. Why not? Oh! Okay, so now the T is failing. I'm getting more and more confused. Oh yeah, because T only works with pipes, so I have to have a pipe, and now P will be the right end of the pipe. Right? That makes sense. So we have this, and then we T it with this guy. So this is this, the T is doing this, so this is T. Maybe I should do, no, I should do a T like this, because that's what T is. Okay. So, and this guy, let's make the arrow longer. This guy is splice, and let's make the arrow longer here as well. And let's make a new line. Let's make this, and this is also splice. Right? That makes sense. I think it makes sense. Well, that's what I think about in my head, at least. Maybe this is the second splice. Yeah, okay. Splice, and this gone. Well, that wasn't very smart. Yeah, something like that. Okay. So let's see if it fails now. Okay, now it works. And if I remove my foo file and I compile it and I cat foo, there's hello in foo. So that part worked. So let me remove the foo file again. And let's attempt our thing. So yeah, let's have two files now. And this will be fd2 notes. Sure, you need this as well. And so, yes, so we, from a pipe to the second file descriptor. That makes sense. Up, and let's run it. Invalid argument on splice 2. But this is a file, and this is a pipe, and this is a file. This is the exact same scenario as this, so I don't understand. I don't understand headmax. What the fuck is headmax? Oh. Wait, the YouTube chat auto-translates it for me? That's so bad. Okay, long max. Oh, right, the long max also. Yeah, you're right. Let's make it, actually, I should make it to be a true programmer. It should be a power of 2. I mean, I don't think it makes a difference, but you're right. We should keep it consistent. Oh! What? That was my long max. Oh, sorry. That was my long max from the beginning. What the fuck? Ah! Why? Am I stupid? Oh, it's size T, but I mean size T is long. Okay, I'm very confused now. What is size T? Size type. I can't go any further. I thought size T was a long max. Yeah. That okay, I don't understand that. Does it say something about size? It transfers up to size bytes of data from this to this. So it's up to. So in theory, I should be able to say like as much size as you can, and it will only copy what it can, and then returns me like what it copied. Does that make sense? I think it does. Does it say anything about size in here? Oh wait, they actually have an example in the man page. That's that could have been handier earlier. Okay. That doesn't make any sense. Okay, anyway, let's move past this because But it isn't ulong technically -1 long. That might trip up. Maybe it wants something realistic. Yeah, I'm not sure. I've seen a couple of examples online where they use like, well, I don't remember now if it was with T or splice or something else. So maybe I was wrong, but I thought I saw that online. And I used that, I think, in my video about like the send file syscall. But okay. Okay, but anyway, it works. I'm decently happy, even though I don't understand fully. Well, actually, we can try. Well, let's see. U long max. Let's say minus 32. Why not? We can test your theory. This, it's also an invalid argument. What about U int max? I mean, I know it's a U long, but I mean, it's weird. U long max is -1. What? Is it though? No, it's not. What is it? So it's a long max. What is long max? It's a shame that my LSP cannot go deeper into what a long max is. Oh, it's CLang as well. Oof. Okay, let's do user include limits. U long max. No, it's hard-coded. Well, I guess it depends on the architecture, but if word size is 64-bit, then it's this. But it seems hard-coded everywhere. Yeah, there's no other instance of it. But anyway, now I'm slightly curious. Let's try the biggest number is in an unsigned is -1 in no, I know that, but no, I know, but I know that -1 is like if you convert it, it's like if you reinterpret the bits, it's like the signed version -1. But that's not what I'm talking about. And anyway, why would it convert it to a signed if the prototype says that it's unsigned? Doesn't make much sense, does it? Let's try int max. See if a smaller value would. Okay, so I mean, what is this? Like I type u int max and all of a sudden it works. I mean, I know it's stupid, but I mean, let's make sure. I don't know. I don't know what seems very weird, but this is 8 bytes, right? I don't know why my editor keeps doing this. Yeah, it is 8 bytes. I don't get it. Yeah, okay. Okay, well, whatever. Let's keep it at something reasonable, and let's make the same choice for T because I don't want to have some weird surprises. So anyway, let's remove this. Let's do this, and then if we get foo and bar, they're both hello. That's great. I would like to do my original example though, of having only one file, and then we, instead of having fd2, we have stdout file no, like so. Like so, and we just have something like this. Yay! Epic. And now we have like, well, we should have a T command, well, quote unquote T command, a T command prototype that is faster in theory, but I mean we haven't benchmarked it at all, so I doubt that I don't know if it's faster. But that was kind of cool. But I mean, since I'm doing some examples for my video, I wonder. Now just add a loop. Yeah. Well, it would be one loop over like this, I don't know, buffer size that I set, and it would be another loop over the arguments to let the user copy over multiple files. But that would be my T. I wonder if there is a better example to showcase this, maybe. Because the T command, I mean, you use it a lot, but it's not the thing you think about when you want performance, right? Like maybe I was thinking before the stream of making maybe I don't know, some kind of network thing that would go into a file, but also to another networking thing, kind of like yeah, just a proxy that would log all the communication on a socket to a file or something like this, and to std out. I don't know. I wanted to have like, yeah, this kind of stuff, and then make the version that would just use read write and then compare the performance. Yeah, high performance network monitoring. Oh yeah, all right. Well, same idea. But maybe we can start with T because it's simpler. All right. Well, let's make a loop. For infinite, we do these. Wait, and T duplicates the. So T, it doesn't duplicate forever. Like this is like this whole thing which I drew above is for a specific amount of byte. It's like per chunk kind of thing. Okay. So yeah, we would have to say like fds is equal to malloc argc -1 like this, and we would have to accept that argv is greater than 1. Yeah, that would make sense, but it would be the size of int times this, so that we can have all the file descriptors in an array, like so, and then we have to say for is equal to 1 until I is lower than C I plus plus. And so we wouldn't do this, we would just do fds I -1 would be this. Yes. Yes. And we can put the die if as well in there. Yep. And this would be if fds I -1. Okay, let's include asset.h. Yeah, well, that was a bit dumb. I have that if and I used assert, but whatever. Whatever, let's roll with it. Do I need a pipe? I guess I do need one pipe for the yeah, for the std out, or for each file. Yeah, because this splice advances stuff, so I would need a pipe per yeah, per thing. Okay, let's just do the same thing here, I guess. Pipe t times argc -1. I guess we can just do I don't know, file count. File count and file count, file count, and then we will do something like this. Yeah, I guess it might be a bit cleaner to do this plus one here, like this, and this would just be file counts, and then we would have the same loop, like so, and we would call a pipe for each one of those, like so. Okay. Oh, I should have copied the example. Yeah, whatever. Because in the video it's always much nicer to start with a very simple example, but whatever, I'll rewrite it later. I wanted to define buffer size here to be 128, 1020. I don't know why I keep putting 8 there. So we have an infinite loop, and this will be replace this by buffer size, like so. Then we would do again this loop, like so, up. We would do all of this inside of this loop. And so the first thing to do is duplicate stdin into the pipe. So that's piece I. Then you splice the I think it would make more sense to first splice from the pipe into the file. So that's fds I, and then you splice stdin to std out. That makes sense, right? So from create a ton of pipe, you duplicate the stdin to each one of those pipes, then you splice all of the pipe to the files that they are associated with, and then you splice stdin to stdout. I think that this makes sense. Maybe let's do this. And so, yeah, I don't know if we care too much about this, but sure, we can close everything. So this would be fds I. This would be this. And let's see if this compiles at all. It does. And so now I would expect that if I have a echo hello there, and then I output that to a.out, and I have foo1, foo2, foo3. Fuck, didn't work. You need at least a 4K buffer size because that's the page size. Actually, my page size is double that, but we saw earlier that it worked without a 4K buffer. So I think that disproves your theory, but I think my page size is, can't read anything. Doesn't ulimit say the page size? I forgot. No. Stack size. Okay, never mind. I forgot how to get the page size. I think it's like sys something. No, I mean I didn't write this in response to the error, just for performance reason. Oh yeah, no, of course, you're right. But I still think that we should go into Git. I think I have a project here, and then in the malloc code, there is a sys something, a page size. There we go. And there's the get page size, so that we actually know. But you're right to point it out. Let's print it. P equal so, and let's just do return 0 so that we know the thing. Oh, you're right. I thought it was double that. When did I ever see this? I guess there is so many of these values that that are here that I keep forgetting. Man to get page size. What does this return? An int. So we can just do a int page size. Is this? Like so, and so it won't be buffer size. It will be page size. Why not? But anyway, that doesn't change that my thing doesn't work. So okay, well, forgot to recompile it. This. Okay, it blocks. Why does it block? Oh, yeah, of course it blocks. It's like if copied size is equal to 0, then we need to break. Oof! This is the first time of my life I can use a goto in C. That's epic. Don't do this at home, kids. I think on x86 and RISC-V, it's always 4K for normal pages. Huh, really? What is, like, I know there is something that is double that, but I forgot what it is then. Because, I don't know, I think for my... Well, I'm not sure now. Yeah, I guess you're right. I thought here I used something that was 8K, but... Okay, anyway, let's not dwell on it. There are machines with 16K regular page size. Huh. Yeah, I wonder where this page size is used though. I mean, I know it's used in pipes, but like I know that when I do a mmap, it's gonna be like a, how do you say? It's gonna be like per page size. But yeah, page aligned. Yeah, I forgot. It's used in memory page in the hardware. Okay. Well, it works, right? What did I do again? So it was that, and then cleared through everything, and then there is my... Oh, it doesn't work! Fuck! Ah, I need to duplicate it. No, I do duplicate it per thing. Ah, I see. I need to first duplicate it to all of the pipes, right? And then I need to splice it because splice advances the head, and so and this is also wrong, right? This should be something like this. So should be duplicated x time, then for those x time for each one of the file advance the pipes, and then finally advance it once for std in and std out. Hello there. Like how the virtual memory of a process map to physical memory and the CPU MMU. No, yeah, I understand. I'm just wondering where else I saw the 8K size. Because I don't know, I thought it was for mmap, but I guess I forgot. Anyway, does it work now, my thing? Right, let's compile it. Let's redo the test. Okay, now it works. Okay. So this is my super T command. And okay, let's move main to t.c. And now let's do, because I don't want to bother with like the whole rewriting it the naive way and benchmarking it myself and writing all the scripts and so on. So we're gonna cheat. So duplicate rewrite the t file with a naive suffix only using read write syscalls instead of t splice. And now I relax and watch my clankers overlord do the work for me. Yes, you do something. Is this correct? This is the same thing. This is the same thing, but instead of here, it reads into a buffer. And then it writes all, and write all is just, yeah, sure, it's a bunch of writes. And then it writes to std out and all the file descriptors. Yes, that seems good. Now benchmark the two versions and make a plot. Yeah, sure, just benchmark the two versions. And my guess is that what? No. In here clinker. And this directory only. I'm guessing, I don't know what it's doing. Yeah, T and it compiles the other T, that's fine. I'm guessing it's not gonna work. It's not gonna be what we expect. It generates some input, some random bytes, that's fine. Because I saw that the GNU core utils was using read and write. So I am unsure. So what does the benchmark look like? It does some compiling, it runs once with time, it does some drop caches, sure, why not? User bin time, something. I fully trust the clanker. Yeah, make it executable. Yes, it's debugging. What? Do the stuff. Splice T version needs std_in to be a pipe. Indeed. Yeah, I guess if std_in wasn't a pipe, we would just create one extra pipe. And okay, what are you doing? Run one. Okay, it's just doing a cat input. It's fine. Yeah, we would just need to create an extra pipe. It's exactly the same time, but I feel like this is because the input is too small. Because anything that fits in a variable is not worth it. Huh, the read-write version is slightly faster. What the fuck are you trying to do? What? No, that's okay. Okay, let's see what was the benchmark. What was the benchmark? Input is tmp t inputs. Get du sh. Make the buffer size much bigger. You mean for the both versions? Yeah, maybe. Wait, let me first do the how did he call it? T inputs. Okay, it's this. Yeah, sure. Let's make let's resume this guy. Make buffer size larger and increase the input size to our what would be a good benchmark. 1 gigabyte, maybe just 2 gigabytes. I mean, as I said, I saw that the original T uses read and write, so I have a feeling that we're gonna be very disappointed by the end of this benchmark, but yeah. I don't fully understand why it would be. And writing to devnull? Why would you be writing to devnull? Wait, is the clanker doing something weird? Okay, so it's increasing the buffer and removing my page size. Why not? Why not? Yes, do stuff. Wait, what? Oh, okay, it's just the buffer. That's good. Pipe max size. Sure. Oh, you can. So the pipe is not per page. Oh. No, I don't know. What did I want to do? Yeah, I don't know. Oh yeah, I wanted to check the benchmark to make sure that it just doesn't. Yeah, it just redirects to dev null. Okay, out files. Okay, so there is multiple files. That's good. How much is end files? 3. Sure. Let's make it 4 files. Let's make it 4 files. Yeah, it seems to be about the same, unfortunately. Maybe slightly fast. Oh, slightly slower, actually. Naivety runs. Naive is still marginally faster, with dev null as SD out splices zero copy path. Still can't win because the kernel's pipe bookkeeping tree chunk costs more than straight read writes at this buffer size, and the output file write goes to page cache either way. Yeah, as I said, I was expecting to be disappointed, but it still might be an okay example. Still might be an okay example just to showcase the thing. Well, showcase how it works, but I mean the goal of these videos is to also. Okay, it overdid. What the fuck? Why does it always go completely over the top each time? Just, it's okay, my dude. We know that it's okay. Yeah, so I'm guessing I'm gonna have to rewrite something networking related to try to make a point, because I mean, if there is no speed if I can't find a use case where there is a speed improvement, then like this all feels a bit empty, you know? Like I like to tease the video. Well, at the start of the video, I like to quickly show how, look, this kind of application is faster, and then you explain, because then the viewer is engaged, because they can actually gain something from it. So yeah, this example is cool, but it's not gonna cut it. And I think it would be quite boring if during the stream I write this networking oriented thing. So I think I'll do it, I don't know, on my way to work in the train. So now I understand T and splice. So that's actually better. I still don't understand why it wouldn't accept like the max size. That's very, very strange. But yeah, besides that, it looks okay. I think, yeah, there was the... Where am I? Okay, so I need to swap them around. There was the splice move flag, which seems interesting. attempts to move pages instead of copying. This is only a hint to the kernel. Pages may still be copied if the kernel. Let's rehash the clanker because I can't go on the whole internet looking for this, but splice as useful at all. Okay, it's still no up. Yeah, that's a shame. That's a shame. I mean, I still would expect it to be faster because we don't copy stuff into user space. Like the whole copying happens inside of the kernel. But apparently that's not true. I mean, apparently that's not the most impactful change in this case. And I mean, it talks about like page cache, which I don't know what it is, but yeah. Yeah, sure, fetch stuff from the internet. But I mean, whatever, it doesn't matter. Yeah. So this is for networking related stuff. This is useless in this particular example. This is also useless, and this is for vmsplice. Okay. Well, that's a shame. I couldn't showcase the proper stuff. Let me just do to-do.md, write a network monitoring proxy as an example instead. So it would be TCP to TCP, and then there would be a cross here, which would go to a file or something like that. And yeah, maybe another cross which would go to std out. Okay, all right, but let's move on to the next one I wanted to prepare, which is vmsplice. Return 0. CNTL, yes. And funny enough, I saw in the utils, I forgot. It's the core utils, but rewritten in Rust that Ubuntu uses. Basically, they use vmsplice for the yes command, because of course the yes command is the main bottleneck in most applications, of course. And so you really need the yes command to be as fast as possible. And so you definitely need to use vmsplice. If you don't know the yes command, it just outputs y on a one line for forever and ever. So anyway, of course, this was the main bottleneck. So anyway, man to vmsplice. And so what I understood is that vmsplice takes memory and puts it into a file descriptor. Yeah, splice user pages to from a pipe. Oh, from a pipe as well. I thought it was only one direction. Okay, well, but let's read. No, that's not what I wanted to do. I wanted to go in this guy and do something like this. Okay, so splice user pages to from pipe. vmsplice takes a file descriptor, IO vector, which is basically just multiple buffers, the number of segment, which I assume is just the size of this IO vector. Is it though? Not sure. And then a bunch of flags. Okay. So if fd is open for writing, the vmsplice system call maps nrseg ranges of user memory described by the IOV into a pipe. If fd is open for reading, the vmsplice system call fills nrseg's ranges of user memory described by IOV from a pipe. Aha, so damn, that's a bit tricky. That's so like implicit. So if the file descriptor is open for reading, it will put stuff from the file to your memory. If the file descriptor is opened for writing, it will put stuff from memory to the file descriptor. That's very strange. Okay, and they create a pipe for us in between. So the description is a bit strange, because when I read this, I assume that I would have to manipulate a pipe myself, but apparently from a pipe. Or does the file descriptor has to be a pipe? If fd is opened for writing system call maps into a pipe, it says a pipe. It doesn't say the fd pipe. Some of those man pages are a bit, I don't know, like not user friendly. System call fills number. Okay, but I understand. The file descriptor fd. Oh, I guess I just I'm impatient. I can't read. Why don't they put this at the top though? I mean, come on. Put stuff in order. Like first the prerequisites and then the explanation, not the explanation then the prerequisites. So okay, it must be a pipe. Sure. So I assume I can have, if let's say I wanted to like copy my memory to a I wonder where this would be useful then. Because let's say I would want to copy some memory into a network stuff, a network socket. Like, what's the point of doing, like I have a buffer and then I have to create a pipe and then do a vmsplice and then do a splice from the pipe to the network socket. And what's the advantage of doing all of that compared to a simple write into the network socket, since I already have the buffer? So yeah. I guess maybe if you have like a very large buffer, which then, I mean, not even. Yeah, I'm just unsure. But I mean, let's try to make it work first, and then after that, let's try to make an example that makes sense. So IOV points to an IOV structure, that's fine. The flags argument is something else. So unused, that we're not going to use. That is unused, and then there is the gift flag. And that's, oh, okay, that's where the optimization can come in, right? So the user pages are a gift to the kernel. Basically, that means that it won't copy them. It will like move them to the kernel. The application may not modify this memory ever, otherwise the page cache and on-disk data may differ. Gifting pages to the kernel means that subsequent splice can successfully move the pages. If this flag is not specified, then a subsequent splice must copy the pages. Data must also be properly page aligned, both in memory and length. So yeah, I guess to come back to my earlier example, if I do this whole chain of pipe, vmsplice, and splice with this flag to give my memory to the kernel, it would actually not do a copy of my memory. So that's the advantage, because if you only do a write, the kernel has to duplicate the memory from your buffer into whatever it's outputting. Okay, but so the question is, why would you ever use vmsplice without this flag? Like, this seems like a useless syscall without this flag. Like, performance-wise. I mean, you can still use it, but like, what would be the point? Upon successful completion, blah, 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 pipe transfer, -1 if there is an error. Yeah, that's fine. Yeah. Node vmsplice follows the other vectorized read-write function types when it comes to the limitation. Yes, whatever. Read support. vmsplice really supports true splicing only from user memory to a pipe. In the opposite direction, it actually just copies the data from user space to user space. But this makes the interface nice and symmetric and enables people to build on vmsplice with room for future improvement in performance. I see. Yeah, right, because there is the other way around as well. Okay, well, let's try to do something. Let's do this. We have to do define new source stdio. Let's do stdlib. Let's sure. What was it? T and splice. And T, and let's just copy this. Up. And now we'll need the pipe, so let's copy this as well. Okay. Then to make the example like real, I will have to do a mmap, right? I mean, otherwise, does it make sense? I guess it could make. I mean, if I do like a malco, if I do a malloc of something, like, and then I gift my memory to the kernel, like the malloc will just, like on the next malloc or on the next free, I assume the malloc will crash, or some undefined behavior will happen, right? So malloc wouldn't work. If I do my my data as a stack buffer, I imagine it's the same thing. Like, it doesn't make sense to give your stack to the kernel. Like, it doesn't make any sense. So I assume, in this case, I have to do a mmap. And mmap is like overloaded as shit, so I never forget what are the arguments. So first is a hint address. I think this can be null. I think the length can be whatever the length I want. So let's do this for now. Oh, it's page aligned. So sure. I mean, whatever. It will align it to the page. It doesn't matter. Prod. Read writes. I forgot how it's called. Then the flags can be 0, the file descriptor can be -1, and the offset can be 0. A prod flags, oh no, flags needs to be like mmap, no, me, moose, something like this. Sys mmap mman.h, man, why man? So it's prod read, and it has to be right as well. Yep, and it's not mmap, it's map. Okay, so now we have our data. Let's just set all of this to A. Why not? So apparently memset isn't there. Memset is in string. Can't I type? What is wrong with me? String.h. There we go. Okay, and then no. Do I unmap it? Unmap it? Not sure. And so let's do this, and right now let's assume that std_out is a pipe, and so we would do vmsplice std_out, the vec would be iov this, and iov is equal to this, and it would simply be iov base is equal to data, and then iov length, I think, is gonna be, yeah, whatever the length is. 3 pipe, forgot, it's len. So this would be iov, this would be just 1. The flags would be 0 for now. Like so. Let's see if this works. No, it will be vmsplice. And let's just do a.out, and we need to have a pipe, and this pipe will just go into cat, because why not? Terminated by segfault. Really? Huh. Okay. So number of segments. Segfault. Why segfault? Let's just try. Maybe I just forgot how. Okay, I just forgot how mmap works, I guess. Data is different than a return value map fade. Let's check if it works. So 7.h. So it is map failed. I forgot how to do this. So let's just check out how past me did it. So the address int. So the size comes second. Yeah, that makes sense. The protection flag redirects. Oh, has to be private as well, right? Because otherwise it would need. Yeah, I forgot. Why does it need to be private? Create a private copy on rate mapping. Updating to the mapping are not visible to other processes. Yeah. I forgot. This might be... Okay, it was just that. It was just that. Okay, I have to... Yay! Okay, that was cool. And so... So if I do vmsplice, and the flag is a splice f gift, like so. Okay, now it works, but it should be faster. Did you notice that it was faster? I hope so. So now if I do data, if I try to overwrite the data, sure, we can make this a car pointer. If I try to overwrite the data, what? It doesn't crash? That's crazy. I just gave my memory to the kernel, but it did not crash. That is odd. That is very odd. Can I can I unmap the memory? Or will the unmap crash? The unmap doesn't crash. Yeah, what indeed? Maybe it's just like undefined behavior. What is going on? This works, right? Okay. What if I vmsplice again? Well, I guess I don't need this. I mean, surely this will fail. What the f... But wait, what if I do a hash so that we can, like, maybe notice it? It says the page cache and the data on the device will differ. The page cache, what's the page cache? And the data on the device will differ. So the device would be std out in this case, or just my terminal. Oh no, it's there. Wait, I missed it, but it's there. Okay, this is extra confusing. Can I just overwrite the buffer, the entire data, and then... Oh, what the fuck is going on? I don't get it now. This is weird. Can I do less data? I mean, I know like that mmap will do the whole page, but I mean, just for the sake of the experience, size is gonna be equal to, I don't know, 32. It's gonna be size. This is gonna be size. This is gonna be size. And this is gonna be size. Right? Okay, so we have a bunch of A's. Then I override that with a hashtag. And then we only have hashtags. Okay, let's make it 2 times smaller, just so we can view this. And then I remove that. And it's just that. Huh. So my only guess as to what's happening, I mean, it's kind of weird that the kernel doesn't make me segfault as soon as I try to write to this. But my guess as to what's happening is that we have some data. Here we give it to the kernel, but the kernel didn't write it to std out yet. And so here we override the data that is now also shared with the kernel, and then it queues another, like, write, another splice. And so, yeah, that's my guess. That's that when we do this, the write didn't happen yet. That's weird. I mean, they have a whole non-block flag, so I assume this is blocking. And so if it would be blocking, that would mean that the moving of information would happen with the first buffer. Okay, well, it's unclear what's happening, but at least it works, and it worked faster than the T and the splice. Okay. Man to poop. vmsplice. The gift. The user pages are a gift to the kernel. The application may not modify this memory ever. Well, apparently this is wrong. Well, may not. It's not like cannot. Otherwise, the page cache and on-disk data may differ. Ah, that's what you meant, okay. But there is no on-disk data. Otherwise, the page cache and the on-disk data may differ. Gifting pages to the kernel means that a subsequent splice can successfully move the pages. But we saw earlier that splice move doesn't do anything. Data must also be properly page aligned, both in memory and length. Hmm. Let's try this with a file instead of a... Well, it has to be a pipe, they said. Why do they talk about on-disk data if they are telling me that it has to be a file? Okay, well, whatever, let's try it anyway. Yeah, I think it's just undefined behavior, and in your case, the kernel isn't doing anything with the pages. But it could. Well, it is doing something with it because it writes it to stdout, but yeah. You mean it could be moved around or something? Or it could write data to it. Yeah, I don't know. Like, this is read-only. Yeah, I'm not sure. Let's try it with a file. Int fd fd is equal to open. It's gonna be foo, and this is gonna be o. Write only. Truncate o. Create. There we go. We have a file now, and we're also gonna need a pipe tp, and then we're gonna create a pipe in the array of this. And so we're gonna splice we're gonna vmsplice into p, right? And then we're gonna, well, I mean, splicing, maybe it's a bit stupid here, because I can just do dup2, right? I think I can just do dup2 to like overwrite the read end of the pipe. Or is it stupid? No, because I need to move the data from the pipe to the file anyway. Yeah, dup2 is stupid, I think. Let's use splice again. So it will be from read to, so this is null, then it will be fd, and this will be null. And then the length will be just size, and the flags will be 0. Sure, let's try it. Like this. like this. And cat foo. And it worked. Okay. Okay, and I assume my FD can then be like a network socket. Yeah. And then I think maybe, yeah, I guess maybe a useful use case would be that, I don't know, if you have like very large, large amount of data, like if you're transcoding a video maybe, then you mmap a larger amount, you write to this mapped memory, and then you can transfer this memory to your network interface or to a file without having to copy stuff. Yeah, without the kernel having to copy the buffer. Because if you did a write, then the kernel would have to copy your thing. Okay, but that's neat, I guess. Not sure how I would benchmark this. I guess I would do this. Maybe I would replace the file with a network thing to be, maybe it's faster. I mean, I don't know. And then and then I would make this mmap just a lot larger and see if it improves over the version that would just write to the file descriptor. I have to also keep in mind that I should be benchmarking like the CPU usage and not just the time it takes. Because I saw in my send file video that it took exactly the same time, I mean almost, but the CPU usage was 2 times less, so sometimes it's just a question of CPU usage. Anyway, I think that's all I wanted to explore for this stream, so I think I'm gonna end it here. I hope for the few people that were here that you found it interesting, and yeah, I'll see you in the next one. Well, if I can. Oh, there's the end stream button. Yep. See ya. Oh. Wait, if you use cat isn't going to... Wait. Wait, if you use cat isn't going to a character device, right? It's going to a character device, right? Isn't that why kernel isn't moving the pages? If you use cat, it's going to a character device, indeed. Isn't that why the kernel isn't moving the pages? Well, I mean, it has to, like, eventually move it from my application to the device, right? No? I don't know. Sure, let's redo the example. Let's do this, and then let's do std out, like so. Oh, yeah, maybe we can do this example, but now we can do it twice and do the same weird stuff we were doing before, so like so. Is this what you mean? So now we will be able to see let's remove foo, let's do this, and now it's cat foo. Oh, and now it's different. Okay, I have no clue what just happened. Well, no, wait, what am I saying? It's exactly the same thing. It was also that way, right? I mean, I don't think... No, it wasn't. Indeed. Okay, this is extra confusing. This is extra confusing. So, std out file std out file like so. There's no need for pipe or file now. Okay, this is not what I meant. I meant that the splice is not necessary anymore. This is std out file, you know. This is std out file, you know. And no, yeah, that's what I want. Yeah. I mean, I think I should just look up what this means. But I mean, this is undefined behavior anyway, so undefined behavior means undefined. So there you go, it's undefined. We have confirmed that it's undefined. Okay, but that's good to know. Anyway, thank you for showing me this. And now I will end the stream and probably go eat. Alright, see ya! Yeah, no problem.